and we are off to the races. Okay, now remember, I have posted the PowerPoints. They're in a zip file. Y'all, that's the easiest way for me to get them out there. It'll might take a couple of minutes when you click on it, that folder, for it to open up. Just be patient. It'll open. Once it opens, you can open the PowerPoints, print them off. It's up to you whether you want to print them off and bring them to class. I kind of appreciate it if you would, because I did that for you to help you, because y'all, all your formulas for the most part are going to be there. So it'll help you, okay? And, you know, you won't have to focus so much about writing formulas and stuff. You can listen to me explain stuff, okay? And then you can write and jot notes as you go. And you know, I think it helps, okay? So I give that to you to help you. Okay. All right, now remember, this is just a refresher in what we were looking at, and I went ahead and wrote these formulas. There's your two more formulas. Remember, we talked about the components. If I want to know the magnitude of a vector, now again, what is the magnitude? It's a scalar quantity, right? It's just a number. That's all it is. If I want to know its magnitude, like if we have vector A, and it's, I don't know, 5 meters, and vector B, it looks a little bit longer, 6 meters. I want to know what the resultant is going to be, okay? What is my resultant going to be? All right? That is how I find the resultant, that right there. So what do? I have to add up the components. If I'm adding the vectors A plus B, I have to add up my AX and BX, and add up my AY and BY, and then that goes right there, and I take this, what I call the square root of the squares. Where does that come from? The Pythagorean theorem. Okay? In a sense, that's like, now I said it's like the hypotenuse of a right triangle. That's where we get the square root of the squares. Okay? Don't forget to sign in, okay? All right. Okay? Then when I want to find the direction of that resultant, the magnitude of that resultant vector, then I use what? I use arctangent. We know it winds up becoming this. You know tangent theta is going to be equal to what? Arctangent, inverse tangent, y over x. And remember what we said tangent actually was? It's actually the slope of a line, except we're only looking at the direction of the slope. We're not looking for the value of the slope. Does that make sense? Because it's in degrees. We're just looking for the direction of the slope as it relates to the origin, not the actual, like, okay, the slope is, I don't know, 9.8 meters per second squared. Okay, that's the value of the slope. It's actually the direction of the slope. If you want to get technical, that's really what it is. It's all tangent is. Okay. All right. Any questions on that? Okay. Then, of course, we had, how do we find components? And y'all, A is just A. It's just, it could be like force, or it could be velocity, or it could be acceleration, okay, or it could be momentum, okay. A is anything you want it to be, okay. So AX, remember, how did we do this? We said it was what? A cosine theta. Again, this goes back to our trig rules of a right triangle, okay, the trig rules of a right triangle. And AY is what? A sine theta. And y'all, you're going to use that a good bit in here. So 1, 2, 3, 4, bam, right there. Just a quick refresher. 1, 2, 3, 4. We're going to use those right there a good bit. Okay? When I talk about components of a vector, All right? That's like saying, what are the parts? What is X? What is Y? Okay? Component is a part, like the leg on a table. Okay? All right. And it seems like, you know, every year I've ever taught this, we're a little fuzzy with that word component. What do you mean by component? It's just a part of the vector. It's the part of that particular vector. And where is the vector? Again, there's your vector. Here's your other vector. You want to know what the x and y is for that one, and you want to know what the x and y is for that one, because they all have x and y components. Okay. All right. I hope you understand that now. Okay, now how do we add in the unit vector? Okay, y'all, the only thing we do with the unit vector really, again, is just put the ij notation. I is x, j is going to be y, and k is z. Now we don't really get into a lot of three directions in here. Now we will a little bit when we get into electricity, when we get into flux, a little bit. But for the most part, with motion, we're going to look at two-dimensional motion. You know, that's as far as we're going to go. And trust me, that you'll be happy that that's all we're going to do. Okay. And I mean, really, three-dimensionally, it's just one more component. It doesn't really change anything. You just add it. It's just more calculations. You just add another component. All the rules are still the same. It's still the same. Okay. All right. So notice that the magnitude of there's your definition. Now, I'm not going to ask you definitions on the test. I might ask you, well, you know, you need to know what velocity is. You need to know what speed is. You need to know what acceleration is. But am I going to put a lot of definitions on there? No. I'm going to put more conceptual stuff. Like if an object has if an object has constant velocity, what is its acceleration? Well, you should be able to tell me it has no acceleration. And I know I haven't gotten to that yet, but I'm going to ask you things like that. That's multiple choice. I will ask you a few terms because you got to know terms. You do need to know terminology. All right. So again, notice it has a value of 1. All right. Well, that makes it very easy. So we can actually express when we get our components. Now watch this. For example, if we find the components of vector A, let's just say that vector right there. A has an x. The vector components of vector A would be what? Well, we might say, I don't know, that looks like about 5i plus, I don't know what, 3j. Yeah, it looks like about a 3. And then I'm going to put my units out there in meters. And that's how we would express the, don't forget to sign in, the components, the ij components for that vector. We just use unit vector notation. Then if we had another vector, and I come in here and drew a b vector, all right, and then I'm going to express it in ij. And so, all right, we're going to say then the unit vector, let's say, what's that going to be? Now, that's going to have a whole lot higher y and a whole lot less x, isn't it? So we're going to say that's about a what? About a 3, I'm going to say 3.5. 3.5i. Now I'm just eyeballing it. I'm just using scale here. And that would be about a what? What would we say on the y? That'd be about a 6j meters. Now, okay, now I say we're going to add a plus b, and I want you to give me the magnitude, the r magnitude, the resultant of those two vectors added. Okay? All right? So how would we do that? Combine like terms, that's right. So we're going to say what? We're going to add the i's and add the j's, and so we're going to have what? Yeah, we're going to have what? 8.5i plus what? 9j? Now, and that's in meters now. But now wait, we're not done. We got to find r. So r is what? Square root of the squares, isn't it? So 8.5i. Is this kind of starting to make a little sense now? 9j. Now I can leave the j's and the j's off while I'm doing the calculations, all right? And then we get an answer of what? Well, that's square root of the squares. That's what? 8.5. Use the calculator here. 8.5 squared. Oh, shoot. Where's the square button? Ooh, Lord, help me. Well, oh, there it is. Shift squared. All right, plus 81. And then take square root. 12.4. Everybody got 12.4? And that would be 12.4 meters. Booyah. Okay? That's easy enough, isn't it? Now, but we're not done. I want to know what direction that is. Now, okay. Now how do we find the direction of those two vectors added? Okay? It's arctangent y over x. And y is 9 and x is 8.5. And so we get an answer of what? 9 divided by 8.5. See, we're working problems already. And then take the arc tangent or inverse tangent, however you want to say it. Oh, now wait a minute. All right, 9 divided by 8.5. There we go, arc tangent. Oh, shoot. Okay, don't do what I just did. Make sure your calculator is in degree mode. Mine's in radians. All right, so I got to put it in a degree. Oh, shoot, how do I do that? Crap. Is it 1? Oh, I'm fixing to sling it. It's Casio. Yeah, it's not hard. Let's see, scientific. Hang on a minute. Shifts. Let's see, mode. Mode. Oh, I know how to do it. I just got to dink with it. I'm under pressure. Y'all are all looking at me, and it makes me nervous. All right. No. Mode. All right. Shift. Yeah, it's supposed to not do that though. It's supposed to be able to hit mode and then the number. It's supposed to work, but it's not. It's not changing. Anybody want to try? Anybody want to try getting it in there? I can use my TI. It's right. That one's old. I know how to do it on my other one. That's an old Casio there. All right, so we get what? 9 divided by 8.5. And then arc tangent. And we get 46.6 degrees. Sorry about that. Everybody get that? See if we can get it back. I used to know how. I hadn't dinked with that one in so long.
It's degrees now.
It's in degrees now? Okay, thanks. What'd you do?
Mode and then a number.
Well, that's what I was doing. I swear that's what I was doing. Okay. Dumb teacher up there. Oh, don't know why I have a wrong calculator. All right. Okay, yeah. All right. Yeah, that one's on me. Eggs on me. All right, now. Okay. 46. Y'all can do everything with electronic stuff. Man, y'all can turn the lights on in China. What are you talking about with your cell phone? All right, now. I mean, really, y'all can do all that kind of stuff. Okay. 46.6 degrees. Some of y'all crack me up the way you type on a cell phone. My daughter can fly, man. I'm like, what are you saying? And I'm like, 3 paragraphs. I'm like, good Lord. All right, let's draw that resultant now. Where would that be? Now, notice right here, y'all. Look. 8.5i. Well, that's not good. That's okay. Yeah, I cleaned it, but I meant to. All right. So 8.5i. It's actually got to be a little bit higher on the Y, on the J, than it is on the I. So that's going to be hard to draw. That's pretty close. Right? That look about right? Does that look like about 46.6 degrees? It's pretty doggone close, isn't it? Huh? Y'all know what we're doing now? Y'all feel good now? Up 0.6. Y'all, that's all you do. That's it. That's unit vector notation, adding, and you add your like terms, you do the components. What if we did not have the ij, but we had the endpoints? What if we had the endpoints of the line? Like, your coordinates. Okay. Then you're going to do this to find the resultant. You do this right here. x2 minus x1, y'all already know this, squared, plus y2 minus y1 squared. If you have the endpoints, now notice I said endpoints. If you had the endpoints of the line, this is to find the magnitude of a vector. I write like Charlie Brown's teacher, don't I? Somebody snapshotted that in the other class, and my daughter saw it, and she was cracking up. She sent it to me. All right, that's all right. I don't care. All right. Find the magnitude of a vector from its endpoints. Okay? That's for the endpoints. Okay? So if you know the coordinates, if you know the endpoints, then you can still find it. You can still find R of the two vectors if you're adding them together. So it's not impossible. Okay? Okay, does that make sense? That goes back to what? Algebra? Some trig? And I don't know if we do that much in calculus. I can't remember. Okay, some of my calculus slips. So, all right. Okay? All right, and that's it. But I probably won't use that, but I wanted to show it to you anyway. Okay. Because you knew that already. All right, now, as far as the product, the vector product, the scalar product, again, this is a review of some calculus and some trig, where we find the scalar product when we're adding vectors together and we want to find the actual angle between the two vectors. We can also do what is called the scalar product. And our equation becomes, and now this is a little bit, they got so many equal signs in here. The equation is actually this. It's the dot product is equal to the cross product. AB is a cross product, right? And that's phi or phi. Come on, you fraternity people. I know you like phi better phi. Okay? And so we find it which way? To find the angle, then, it's going to become what? Let's write it down here. To find phi or phi or pho or fum, it's going to be the dot product divided by I'm going to write it this way. Oh, I left something out. Dadgummit. Getting in a hurry. I'm thinking ahead. Arc cosine, and we're going to do a problem of this, okay? All right, now let's do the dot product AB. Okay. So if we're looking for the angle, we can find the angle between two vectors by using what we call the scalar product. Now, do we always have to use that? No, we just can. It's just another way. Okay, that's just another way. All right. Okay, so there's your another equation, and that's called the what? The scalar product, and that's on page. Oh shoot. Yeah, page 20 and 21. Yeah, page 20. That's on page 20. Page 20. Okay. So there's your another equation to add to your card if you want to put it on there.
So the AB on the bottom, it's just, you said, I don't know if you meant to say it, but you said your cross product.
Well, you're going to take, yeah, because you're going to, well, it's actually the is it the vector product where you take the components and square them? All right, he's asking, he said it's the cross product. What it is, look, and I have to work a problem. When we do the dot product, for example, if we have A is equal to, 2i plus 3j, and B is, 4i, minus 6j. All right. We get our top numbers by doing what? Multiplying our i's, right? Okay. But the bottom one we get by what? By squaring these, and then it's under the radical. So it's like we're finding the magnitude. It's actually the magnitude, the magnitude of those two vectors. So it's not the cross product. I said the wrong thing. Because look, what we'll do, and we're going to work a problem, and I'll show you here in a minute. We're going to square both of these, add them together, and then it'll be under the radical, and do the same thing for b, and it'll be on the radical. Then multiply both of the numbers under the radical, and then we divide, and then we take the arc cosine. Okay? Okay. Yeah, thanks for catching me on that. Yeah. Okay. And we'll work one. You'll see what I'm talking about. And again, I don't spend a lot of time. I don't like necessarily, and this does have purpose. I'm not saying it doesn't, but again, I always like to find the angle between the two vectors using arctan. It's just easier. Okay. But you can do it this way too. Okay. You can do it this way too. Just another way to show you. Okay, and that's just more of the same. Now, you don't have to write this down. Calculating the scalar product, again, that's just talking about how we do it. Notice that we're adding all the like terms. Now, what if you have a z term? Well, you just got to make sure that you add all your like terms together. Okay? They give you an example problem on page... Oh, is it page? I was thinking there was an example problem. Well, they don't actually give you a problem, but they give you the formula and they spread it out. They actually expand it out and show you how it's done. On the bottom of page 23, how it's done. And they just make sure, notice you do A and Z and B and Z, and then of course A and Z and B and Z, B, Y, and Z. You cover all your terms, okay? And so when you multiply them all out and add them all up, you have multiplied and you've added all your terms together. In other words, you've covered them all. And they show it on the bottom of page 23, how that's done, okay? If you have, again, the Z axis. Now, most time, we're not going to have Z. We're just going to keep it X and Y, okay? All right. And that's just an example. Now, here's another way. And again, I've not done this in times past. Can we? Yes. Another way to find the vector product is take the magnitude, to find the magnitude of the vector. Here we do the cross product. I was getting ahead of myself. So we take the cross product of AB and the sine of the angle. Okay? To find the magnitude of our two vectors. Okay? So here's another way to find magnitude. Okay? And we do this by what's called the vector product. Okay? So it's a little bit different. Notice we're not using the square root of the squares. Okay? Okay. Okay, and that's just showing you how it's done. Y'all don't need to know how to do that because you've done that in calculus, okay? All right. Come on, end. Okay. But again, I typically don't work problems that way. I don't know. Typically in physics, we like to find the components, we like to add our like terms, and then we do the square root of the squares, and we use arctangent. That's just really the easiest way to do it. I mean, that's just the way I've always taught it. But there are other ways, and I just wanted to show you that, okay? And if you want to use other ways, fine. Okay? I don't care. But typically, that's just the way I've always done it, okay? And that's the way I've always seen it done. So, all right. Now let's go back to our problems. Y'all don't have any questions. Do I want to save that? There's really nothing to save. All right. Chapter 1, I believe it was. Because I know we were still a little fuzzy on some of these. And I may back up a little bit and add a few more problems to that list for us to look at. Because I think I had a couple of people, and I don't know if it's in here or the other class, that emailed me about converting. Still not a little fuzzy on how to convert. So we might back up and look at one of those. Let's see, what problem was on? Number 24? Yeah, I think it was number 24. We were already looking, I'm already looking at chapter 2. Yeah. All right. Yeah, number 24. Number 24 is kind of long. Okay, I've done the first part of it. Okay. All right, there was our final answer for part, I believe it was part A, where we added A plus B. It was 9 meters was the resultant of the addition of A and B, and the angle was 33.4. Now let me say this. I'm telling y'all, it really helps you to draw the X and the Y, just like this. Draw where your magnitude is. Label that angle. It really helps you to understand what's going on physically. I'm telling you, it helps you. It helps you to see, oh, I see why that's the way it is now. Because both those numbers are positive X, positive Y, it's got to be a first quadrant. See, that right there will tell me when I do my angle. That right there will tell me. See, look, positive X, positive Y. A little bell ought to go off in your head. That is first quadrant. That means when I do my arctan, I better get an angle that's first quadrant angle. If I get something crazy, I've done something wrong. Okay? I'm telling you, and y'all, we all make mistakes. We all punch a wrong button on a calculator. We do it all the time. I did it. I couldn't even get the thing in stupid scientific mode. All right. Okay, it's because y'all were staring at me. I was under pressure. Okay. You think after all these years I wouldn't get nervous, but I do sometimes. All right. All right. I'm just human, I guess. All right, let's look at B. All right. Okay, and y'all may have already finished this out. If you did, great. The vector difference, okay? Well, the vector difference, that's a B, believe it or not. I wish my pen would work. The vector difference, A minus B, okay? All right, so what do? Well, we know A was what? A was a vector of 8 meters, so let's redraw it. A was 8 meters. That was A, right? Yeah, this is A, and then B was somewhere over here. This was B, and that one was what, 15 meters? Now remember, y'all, that's just the length. That's just the length of that arrow. That's the distance from the origin. That's the distance from 0. That's really how you look at that. That's the distance from 0. That's really the, what's the correct polar coordinates? Except the only thing is, not necessarily polar coordinates. How do I want to say this? That's the distance from the origin. When I add the angle in there, then that gives me the angle from the origin, or the angle from the x-axis, positive x-axis. So that is like a polar coordinate, similar, except it's not the endpoints. We're not talking about endpoints. Okay, so we've got to be careful. Okay, I'm not talking about endpoints. All right, now, okay. So A minus B. So what do? Well, we've already found the values for those, haven't we? What was AX was what? Now see, we've already done this. AX was what? 0 meters. AY was what? At -8. And then BX was what? 7.5. So we've already done this. And then BY was what? 13. Right? Okay. All right, so now what we got to do is what? All right, we've got to make B negative. Right? Okay, so we've got to subtract. We've got to make B negative, so that means what? All right, AX minus BX. That's right. So we have, of course, AX is 0, and BX is what? A negative 7.5, isn't it? Because B is negative, right? Right? Because look, we're subtracting, we're making B negative. Right? Okay. All right. And now we're going to do what? Well, AY is already negative, and BY becomes what? Negative. Right? Now this is X, and this is our Y's. Right? Everybody with me? All right, now let's add that up. And what do we get? We get negative 7.5. What? Minus what? 21? Y'all watch my math now. Is that right? Okay. All right, now let's do what? The square root of the squares. We got to find the resultant because it said what? It said find the magnitude. So we do what? Square root of the squares. So we get negative 7.5. Well, we know that's going to be positive. Plus negative 21. And we get an answer of 22.3 meters, right? Everybody with me? Uh-huh. Now notice how that changed. Because now B is actually in what quadrant? Before we do arc tangent. B is now in what quadrant? Very good, third quadrant. Basically what we did with B is did what? Flipped it. Yeah. Very good. All right. All right, now let's do arc tangent because we've got to get direction. Right? Okay? And okay, y'all. Plug and chug, as Mayhaw would say. Right? Both are negative, correct? Yeah. Negative 7.5, negative 21, yeah. And so we get an answer of what? That answer comes out to be what? Let me do it before I actually... Let's see, negative 21. So negative 21 divided by... phooey. 21 negative divided by 7.5. And... All right, we get an answer of 70.3 degrees, don't we? All right, but now wait a minute. Is that my final angle? 70.3 degrees. Everybody get that?
Yes.
Okay. But is that the answer I want you to put down? No, absolutely. Because, let's draw it. Now see, here again, this is why you need to draw it. All right, where are both of you? I've already said this. Where are both of my x and y components? Third quadrant, so draw it. Let's see, x is what, 7.5, and y is what, 21? Good grief, that sucker's long. Going to look something like that, isn't it? A lot bigger y than x. Okay. All right, so, all right, and I know that don't look like a 70-degree angle, but just pretend. Okay. All right. So now what do we got to do? Well, we got a positive angle. So what do we do with that positive angle? We're in the third quadrant, and it's 70.3. So I'm going to do what? I'm going to add it to 180. And I'm going to get what? 250.3 degrees. Now here is where we stump a toe. Well, now, Miss Shields, how'd you know to add? Okay. Well, all right, it's in the third quadrant, right? Right before we go into the third quadrant, what angle are we at? 180. All right, you move on down, and the angle, the answer we got was what? Positive. Positive. You're right. Positive, but we add it to 180. We don't subtract it, because if we subtract it from 180, then we're back up in the second quadrant. We add it to 180. Okay? And so we get what? 250.3. What if I get a negative? You get a negative angle, yeah. And you'll see what I'm talking about. We'll get to some problems where you'll get negative angles. You look at what quadrant it's in, and you say, oh yeah, I'll have to subtract it from either 180 or 270 or 360, and it works out perfectly. Okay? And that's why we like to do it this way, because remember, we're referencing it back to that positive x-axis counterclockwise, and folks, you are right when you do that. You don't go wrong. 70.3 is deceptive. Automatically the brain wants to tell us, oh yeah, first quadrant. No. No way, because those numbers are both negative. Okay, so you got to be careful. All right. And that's the answer I want to see on the test. That is the answer I want to see on the test. Okay, everybody with me? All right, now this last one, boy, they really mess with us. The last one is what? Negative A minus B, okay. So this is what? C? It's not the last one. Actually, there's a what? Is there a D? Or no, it's C. C's the last one. C. All right, so we got negative A minus B. And so we already know all our parts, don't we? And so now it becomes what? We can do it a couple of different ways. 7.5, again, this is 0 and it's negative 7.5, isn't it? Because here's our x. Plus, now it's negative b. Okay? So, what happens to our 8? 8 becomes positive, doesn't it? So it actually, I'm going to do this, y'all. I'm going to go ahead and, I tell you what, you want me to do it this way? I can do it one of two ways. Let me do it this way. It might make some of you math geniuses feel better. And I guess it would be mathematically proper to do it that way. That make you feel better? Okay. All right. All right. Minus 8 plus 13. I probably should have done it up there on that one too. So it actually becomes what? Positive 8 minus 13, right? Is that right? Okay. And that's your y terms. And so let's go ahead and write it. 0.0. Why did I say 0 point? Boy, it's Monday all over, isn't it? Whew, 7.5. And of course, let's put our brackets. All right, we're going to say plus a positive 8 minus 13. Okay. And now we're going to get a resultant of what? A negative 7.5. So we're going to have negative 7.5 plus a negative 5, right? This is our x, or our I. Now, how could I write that in IJ notation? 7.5i plus minus 5j. That's all you got to do. I could write it that way. Okay. All right. Now what have I got to do? Find a magnitude, right? Y'all probably already done going to sleep on me. 7.5 squared plus negative 5 squared, and we get an answer of what? Well, what do you know? We get an answer of 9 meters again, don't we? Well, no duh. But now wait a minute. We got to look at our quadrants. Y over x. And we got what? Negative 5 over what? Negative 7.5? Ooh, I can't let time get away. All right. Now we get what? Now the angle is what? 33.7 degrees, right? Everybody get 33.7 degrees? Okay. It is 33.7, right? Y'all always double check my math. Sometimes I punch the wrong button and don't leave it and put a negative in or leave it off. All right, 33.7. All right, but now wait a minute. Hang on there, Chester. What quadrant are we in? Third. We're right there. Huh. So what have I got to do? Very good. Add 180. And we get what? 13? 213.7 degrees. There's my final answer. Everybody good? That's what I want to see right there. Now, does that make physical sense? Does it verify the math? Does everything verify and line up with the math? Absolutely. Okay. Absolutely. So basically what we did with that other problem is we did what? A plus B, we kind of did what? We just did what? Flipped it over, didn't we? That's all we did, is flipped it. We just flipped it over. That's all we did. Okay? And I know y'all knew that, but we still had to work it out, okay? I know you knew that. All right. I know you're not crazy like me. Maybe not. Maybe I'm not too crazy. All right. Physics will mess with your mind sometimes. Chemistry will too, especially after smelling all those chemicals. Anyway. Whew, sometimes lab gets rough. All right. Especially when you're using hydrochloric acid. All right. Okay. Let's look at some more. Let's see which we might want to pull our hair out over.
It's that same thing you said, multiplying it to vectors, and you have to use those.
For the, you talking about?
It's A times B. Could you do split them up with the X, Y's, like what we used to do?
Yeah, and do the vector product? You talking about, is that what you're talking about? Yeah. And find the magnitude, yeah. Yeah, should be able to, yeah. Mm-hmm. Yep. And just do the vector product. Mm-hmm. Okay. So you can do it that way too. All right. But you got to know the angle. See, and that's the thing. If you don't know the angle between them, that's the only stipulations. You got to know the angle between the two. If you know the angle between the two vectors, then you can. But if you don't, then you can't. But if you know, let me think about that now. If you know this one's at 60 and that one's at, you still should be able to calculate the angle. Yeah, so you should be able to calculate the angle because you're going to have an angle to do the components. Yeah. So you should be able to find that angle and then take the sine of it. Okay? All right. Okay. All right. I don't know what I want to work. Have y'all looked at any of these? Do I need to go back and do any on the conversions just to refresh your brain? How to convert?
I don't know how you do, like, if it's centimeters cubed.
Yeah.
And you're going to,
Meters cubed?
yeah, like,
Okay.
I don't know how to, with the exponents,
Uh-huh.
I don't know how to
Okay.
convert the.
All right. Glad you mentioned that. Derivation of the liter. Has everybody ever seen that derivation real quick? Because it ties into all this. Anybody ever seen that derivation? Did your high school teacher show you that? Okay. You know how we come about with the liter, right? It was a derived unit. It's not a fundamental unit. It's derived. The liter is derived. How did they derive it? Well, typically liquids are held in containers, right? Which is a solid object. See, like that's solid. And objects have what? Length and width and height. So we can find volume, can't we? Okay. But it's using length, width, and height. So when the SI was developed, they had to derive the unit for liter. And what they did, you remember from chemistry, we said 1 decimeter cubed is equal to 1 liter. You remember that in chemistry? And I'm not answering your question, I'm answering. I'm going to show you how we do this. All right. It comes from this. Because a 1 decimeter by 1 decimeter by 1 decimeter box is 1 decimeter cubed, and it will hold, and that's how we established the liter. We said, okay, this is going to be 1 liter, and guess what? If it's pure water, it has a mass of 1 kilogram. Yeah. At 4 degrees Celsius. And what do we know about water at 4 degrees Celsius? It has a density of what? 1 gram per centimeter cubed. Now, have you ever wondered where we got, if you have a centimeter cubed of water, it's the same as having 1 milliliter of water, which has a mass of 1 gram. Have you ever seen that in chemistry? Your chemistry teachers have told you that. I know they have, because I taught mine that. Well, it comes from this derivation right here. Because look, a decimeter cubed is equal to a liter. Well, a liter is what? 1 liter is 1,000 milliliters. All right, y'all, well, what's a decimeter in centimeters? A decimeter is 10 centimeters by 10 centimeters by 10 centimeters. And what's 10 times 10 times 10? 1,000. So 10 decimeters cubed is equal to 1,000 centimeters cubed. Okay? And if it's a box of water, or if it's water, it doesn't have to be. It could be anything. 1,000 milliliters, which is 1 liter. And if it's water, it has a mass of 1 kilogram, which is 1,000 grams. So you have a 1-to-1 ratio, a 1-to-1-to-1 ratio there. 1 milliliter is equal to 1 centimeter cubed. And if it's water, it has a mass of 1 gram. So I don't need a balance to weigh water, to take the mass of water. For general chemistry purposes, general. Now, not quant and qual. You go into quant and qual lab, by all means, put the sucker on the balance and hit 0. Because you're measuring small amounts. But for general chemistry, we can say 100 milliliters of water is 100 grams of water, boom, let's go. If it's general. Okay. So how do we convert that then to metric and centimeters cubed and meters cubed? And I've run out of slides. Oh, no. Not a big deal. How do we do that? Okay. Well, basically, it's the same principle of what I just showed you. I wanted to show you that derivation of the liter because I know some of y'all had never seen that. Anybody ever seen that? Did y'all know that's where the liter came from, how they came about it? Anybody ever seen that? Good. Well, you learned something new today. Hallelujah. All right, now. So, all right, now, and that was a real quick explanation of that. Now, so if you have a 1 meter, how many centimeters is in a meter? 100. Okay, so 1 meter cubed is equal to what? You got 6 zeros. 1 times 10 to the 6th centimeters cubed, right? Check me on my math. 6 zeros, is that right? 246, yeah, 1 million. Is that right? 1 meter cubed is 1,000,000 centimeters cubed. So now we can convert. You see how I did that? Does that make sense now? Okay. So now you got a conversion factor. So if I have, I don't know, 75 centimeters cubed. Now, if I just ask you how many milliliters is that, what are you going to tell me? 75 milliliters. And if it's full of water, how many grams is it? 75 grams. We're done. But we're not doing that. I said if. All right. All right, now, so we want to convert that to what? We want to go to what? Meters cubed? All right, well, let's factor label it. And I love doing this. This is my chemistry coming out in me. All right, now, all right, our conversion factor is what? 1 times 10 to the 6th centimeters cubed over 1 meter cubed. Right? So we cancel. We divide 75 by, we divide 75 divided by what? 1 to the 6th. I'm putting y'all to sleep, I feel like. All right, now, and that's what? 7.5, I didn't even really need a calculator, but I did anyway, times 10 to the what? 5th? Yeah, -5th meters cubed. So what does that tell us when we compare units? From meter cubed to centimeter cubed, what does that tell us? Well, I think it's obvious. A meter cube is what? Yeah. Okay? All right? You know, if you think about a centimeter cube, y'all, we're only talking, if you think about a graduated cylinder, 100 milliliter graduated cylinder, when you fill it to 100, that's 100 centimeters cubed. Y'all, that's not much. That's not much. And it takes 1,000 of those to equal 1 liter. Okay? It takes 1,000 of those to equal 1,000 centimeters cubed to equal 1 liter. Well, good grief, a liter is what? Just a smidgen over a quart, isn't that right? Conversion factor of quarts to liters. Where's it at? On the inside cover of your book, volume. Yeah, 1 liter. Nah, gummit. Why does it have that one? It doesn't have it. It's got it in gallons. Okay, well it says 1 liter is, 1 gallon is 3.788 liters, so it's, yeah, a liter is just a little bit bigger than a gallon. Or excuse me, a quart. Because not hardly 4 liters will make a gallon. 3.788 liters make a gallon. So that tells me the liter's bigger. Okay. So we're talking about, you know, Not much. Okay, a little over 32 ounces. A little bit, not a whole lot. Okay? All right, any questions on that? All right, did y'all look at any of these problems? Any particular one you want me to work?
Can you work out number 6?
Number 6. Yeah, number 6 is a little bit, it's a little lengthy. Yeah. Are y'all good with the unit vector stuff and adding the components and square root of the squares and arc tangent now? Does that make sense now? Y'all feel pretty good with that? All right, I'll tell you what I want to do. I want to back up from problem number 14 all the way to problem 45 would be legit problems that I would ask you Thursday to come in here, and I'm only ask 2 or 3 people, first to class, okay? And I'm just going to randomly pick 2 or 3, and then next time I'll pick the other 2 or 3. I won't pick the same person. So we're going to back up to 14, the problems 45 that I assigned. That will be legit for me, and yeah, that's what you're going to be responsible to turn in. Everybody's got to turn it in, okay? Everybody. And you'll get it back, okay? You'll get it back, all right? And if you want to see the answers, I mean, I'm just going to give you credit. It's just a participation grade. And I'm going to quick look at it real quick. And then if we need to, we'll go over the answers just real quickly, and I'll tell you what the answers are. All right, now, number 6, you said, right? All right, number 6. A square field measuring 100 meters by 100 meters. Always draw it. 100 meters by 100 meters. Okay. Has an area of 1 hectare. All right. So this is equal to what? 1 hectare. Let me write it this way. If I'm not mistaken, you abbreviate hectare this way. HA. Ha. All right. 1 ha. All right. Now. Okay. 1 hectare. And an acre has an area, A-C-R-E. Acre has an area of 43,600 feet. Okay, that's 1 acre. Squared. Woo, almost left the square off. Now, if a lot has an area of 12 acres, what is its area in hectares? So if we have a lot with 12 acres, we want to know what is its area. So area in hectares, okay, is the question. All right. So we got some converting to do, okay. All right, now they give us, did they not give us a conversion factor there? They gave us the area in an area of an acre is 43,600 feet. They really want you to scratch your head a little bit. So what do we start with? Well, we start with what we're given. We always start with what's known, which was 12 acres. Now, I'm going to use my old chemistry, if that's okay, y'all. I'm going to do factor labeling, dimensional analysis, whatever you want to call it. Same thing. Ratio and proportion, just looks a little different. So we got 12 acres. So we know that 1 acre is 43,600 feet squared. So we cancel out acres. All right, now. Okay, now we've got to go from feet to meters, right? Because a hectare is 100 meters, 100 times 100, and that is what? 1 times 10 to the what? 4th meters squared is 1 ha. 1 hectare. Okay, so there's just another conversion factor. So we're going to get to eventually hectares. Okay, now I've got to go from feet to meters. There's a couple of different ways you can do this, but the easiest way to do it is this right here. We know that 1 foot, now where am I going to get this? Front inside cover of my textbook. Front inside cover of my textbook. Okay, 1 meter is, and I wrote it down here, 1 foot is 0.3048 meters. Now, well, that's not squared. Oh, okay. Square it. I mean, you could go ahead and work that out, square it, and then plug it in. You're going to get the same answer. I mean, it's still going to be 1 foot and then whatever 0.3048. And by the way, you got to use all of 0.3048. You do not round conversion factors. Never. Okay. All right, you with me? All right, now we know what? And we just did the 1 times 10 to the, now notice that's meters squared, so we know that 1 times 10 to the 4th meters squared, so we've got to get units to cancel out, okay, is what? 1 ha, 1 hectare. And we get an answer of, and I'm going to write down 4.86 hectares, right? 4.86 hectares. Okay? Any questions on that? Does that help you now? You kind of see where I got it? Is anything throwing you? What's throwing you? Is this right here? Yeah, front inside cover of your text. It should be. Now that ebook should have the entire book. There shouldn't be any discrepancies. Did you find it? Did you go to the front inside cover? It should be there. Let me double check. 1 meter. Excuse me, 1 foot. I'm looking at it wrong. Yeah, they give it to you in centimeters. They want you to convert it to meters. Okay, if it's 30.48 centimeters, where's meter to centimeters? All right, we got centimeters, meters over here. What's in the middle? 1, 2. 2 to the left, so it's 0.3048 meters. They wanted you to convert. You see what I'm saying? Yeah. Does everybody remember that? Does everybody remember that from junior high? Kim had difficulty making decisions concerning metrics. What's the other acronym for that? Anybody remember? I can't remember the other one. There's something like King Henry died. No, King Henry died while drinking chocolate milk or something. Yeah. That's not very positive either. You know, you don't want to use the word difficulty concerning metrics, because then everybody's going to say, oh, it's hard. No, it's not. And then he died. Well, dear God, we definitely won't do that. So, I don't know. Everybody remember that? You know, I can write that little table up if you want. You shouldn't, start at kilo, go all the way to milli. Now remember, I want you to remember those. I want you to be working on your prefixes. Please be learning them. Okay, the big ones and the small ones, because we will use them some. Especially next semester, we'll use them a good bit. We use them some this semester too, okay? All right, everybody good? All right, what about number 34 is basically find the magnitude and direction of the vector represented by the following components. Can y'all do number 34? You want me to do one part of 34 and let y'all do the rest of it?
Yes, sure.
Yeah, let's do that real quick. And listen, y'all, now listen. Don't forget, go to the study area. There are tutorial videos there. There's like 10 or 12, and they're on each part, okay? The study area, you know what I'm talking about? In Mastering Physics, student study area, tutorial videos. And they're good videos, so don't forget, if you get stuck, if there's one that I didn't work, you can go and look in there, and there should be one there that for each section, okay? That's one thing I love about this book, because they supply that video for you, okay? All right, number 34, is that what I said? I reminded someone of that this weekend. Someone emailed me. And that's okay. Listen, I want you to email me. And if you still don't understand, come by my office, and I'm going to help you. I'm there. All right, so number 34, let's just do A, 34A. 34A. All right, it says, find the magnitude direction of the vector represented by the following pairs of components. Okay, so A, we have AX is negative 8.6 centimeters, and I'm glad they gave units on this, negative 8.6. And AY is 5.2 centimeters. Okay? All right. So now we want to find what? It says find the magnitude, right? And the direction. Okay? Now they've already given you X and Y. So all I got to do is find the what? Very good. Square root of the squares. Now, again, I like to write it R, resultant, magnitude. That's the way I like to always write it. Okay? That means the resultant, the magnitude of the vector. Square root of the squares. Very good. And so we got negative 8.6 squared plus 5.2 squared. Squared. All right. And we get what? 10 meters? 10 centimeters? Yeah. Rounded off. I can't remember exactly. Maybe it was exactly 10. I can't remember. I wrote 10. All right. Now, wait a minute. We've got to find a direction. All right. What is that? Arc tangent? Huh? Yeah. 5.2 divided by negative. That's very important. And we get what? I get a negative 31.2. Is that what you get? Now, is that the angle I'm going to put down? No. All right, let's draw it. All right, what quadrant are we in? We're in the second quadrant. About there. We're not going to get a transient out and shoot points, all right? Close. Remember, close counts in horseshoes, hand grenades, missile shields class, nuclear explosions, tsunamis, tornadoes, and all that good stuff. All right, now. Okay? So, we're going to do what? We're going to add it to 90 or subtract it from 180. Well, that's a negative. Subtract from 180. Very good. See, it works out beautifully. And we get an answer of what? 148.8. Is that right? Huh? Yeah. Yeah. There we go. How'd you know to subtract? Because it was a negative angle. Okay? Okay? Everybody good? Yeah? Okay. All right. Now, number 45, y'all, you're going to do this right here. You are going to use this equation. And it's actually the magnitude of both. Okay? Doing the square root of the squares times each other. Okay? That little equation there. All right? Okay. That's for number 45. Okay? All right. All right, y'all got any other questions? Okay. Thursday. Yeah. And let's back up to number 14. Why am I saying Thursday? Wednesday. Y'all are not Tuesday, Thursday. Man, I'm getting my days mixed up. Lord help, I need to go back home and start over. Wednesday. Y'all are Monday, Wednesday. Why have I got my mind on Tuesday, Thursday class? I don't know. Maybe I want to hurry up and get the week over with. Hey, holiday this weekend. Yeah, long weekend. All right, now. All right. Wednesday. So back up from 14 all the way to 45. That's just about 1, 2, 3. I only added 4 more problems, okay? And try to work on those. If you get stuck on one, come by and see me. We got lab today at 12:30. I might be here 5 or 10 minutes early. 12:30 for sure. We will start at 12:30 sharp, okay? Okay? All right. See you then.